Today's video is about slope fields. We're going to take a look at an exploration to, to investigate what a slope field is and how it works. And then we're going to talk about how to sketch a slope field and then match slope fields to a given differential equation. And then lastly, draw a solution curve through a point on a slope field. So let's take a look at our exploration. As you see here on the screen, we have a differential equation, y equals x squared, dy dx equals x squared minus 1, whose solution goes through the point -1, 3. So first part of the exploration is to calculate the slope at each of these points. So if you look at your differential equation here, our differential equation depends on x alone. So all we're doing is going to substitute value of x from each point into here to get a slope. So the slope of the first point is 8. So you plug in -3 into your differential equation, you get 9 minus 1, which is 8. The second one is 0. Again, plug in -1 into here. -1 squared is +1, minus 1 is 0. Next one is -1. And the last point is 3. So now we can go to part 2. And it says circle the point 1, 3 and use the results from part 1 to sketch the solution to the differential equation on the graph below. And then we're supposed to describe the solution. So here's the slope field based off the slopes here. Okay. You may see a combination of some purple here. So purple denotes negative slopes here when x is 0 and so on. So now we're going to draw a solution curve here. And there's the solution curve. And notice based off the slopes will just tell us about the behavior of the solution curve. So any positive slopes tells us that our solution curve should be increasing near those points you see here. Any slopes of 0 will tell us if we have a max or min depending on the behavior of the slopes to the left and right of it. And also, negative slopes denotes that the graph should be decreasing near some point. So as you can see here, we have a positive slope, 0, negative slope. That's a change in sign based on the first derivative, because that's what dy dx implies, the first derivative. So that means this should be a max at this point here, based on the point given -1, 3. And then here, if you take a look here, we have another 0 slope somewhere here. So it should be decreasing. And the max can be anywhere. It can really be somewhere down here, depending on how you draw the solution curve. But then it starts increasing again here. So your solution curve goes from left to right, and it goes from edge to edge. When we describe the solution curve, it's going to be a cubic function, because we have, if you know the characteristics of the cubic function, the left side of the left tail end, or what we call it, is decreasing, and the right tail end is increasing. So that's indicative of a cubic function. So now we can move on to what slope fields are. So those are slope fields. So by definition, a slope field is a graph consisting of line segments whose slopes are given by differential equations. So you see here you have some examples of slope fields whose slopes are given by a differential equation. So now we're ready to go on to sketching slope fields here. So what we're going to do now is we're going to compute several values of our slopes here. And so what we're going to do is first compute our slopes. Sorry about that. So here's some slopes. So for some x values here, You have a slope of 1/2 when x is 0. So that's positive slopes. For x equals 1, you have a slope of 1/3. And you can kind of look at the steepness of this. And for x equals -2, we have an undefined slope. So that means we have to draw a vertical line. So anytime you substitute a point in here and you get a 0 for your denominator, then you draw a vertical line. If you get a 0 for both the numerator and denominator, you don't draw anything because that's an indeterminate form. So we can't get any information from that. Okay, so that's the slope field for the first example. Here's a slope field for the second example. Okay, so when we do this, we'll have some of these slopes here. Here's some slopes. And you can compute more slopes if you need them. And based off these slopes, here will be the slope field here. That's the slope field here for this differential equation. So every differential equation is different based off of what the derivative is. So if you understand the first two examples, then here is a practice problem for you to do. I pretty sure you can go find on the internet some slope field paper here, but if not, you can freehand sketch by just drawing a few of these points and computing slopes at each of those points based on the differential equation. Here's another one, or actually here's the next example. And so now we're going to be matching slope fields based on the equation. So for the first differential equation, dy dx equals 1/2 x plus 1, can you pick out which one of these slope fields matches this differential equation? So if you are able to do that, well, if you were able to find it, that would be slope field B. And how are we able to figure out which slope field is which? You can tell this is based off x alone. So if you substitute some values of x in, for example, like x equals -2, if you plug that in, you get -1 plus 1, which is 0. So that means when x is -2, you have 0 slopes, which is horizontal line segments. And of course, you can test some other values of x. The slope field that goes with the second differential equation, dy dx equals y, is d. And so again, this is based off y alone. So if you just plug in some y values, you can figure out that you have some slopes here. It's kind of difficult to see for x equals 0, but those are some line segments there. You actually drew them there. So whenever y is 0, you get a slope of 0. And then when y is 1, you get positive slope of 1. When y is -1, you get a slope of -1. For the third differential equation, it will be slope field C. This is based off both x and y. If you notice that if x and y are equal, you will get a slope of 0. So any point along this diagonal here gives you slopes of 0. And of course, that leaves slope field A for the last one. Notice that there's no segment in the middle, because if x and y are both 0, that gives you an indeterminate form. And so that doesn't give us any information. So a strategy to match a slope field with a given differential equation is to look for some 0 slopes and some undefined slopes, and maybe slopes of +1 or -1. That's the best strategy I can give you. So now if you understand that, you can try matching these slope fields, okay? Match these slope fields based off these differential equations. So now we get to drawing a solution curve through a point of a slope field. So we have dy dx equals 2 minus x. So we have the slopes already drawn for us. And here's the point here. And our job is to draw a solution curve through the point. So here is one possible solution curve you can draw, which is that. So as you can see, on the left side of this point, we got positive slopes here. So that denotes that the graph is increasing, and starts to level out as we get near points over here. So it's increasing. And then when we get over here, that should be a max. And then our graph should start decreasing based off these slopes here, because these slopes are negative. Okay. So from edge to edge is how you draw the slope field. And you can tell this is a parabola. So that will be the solution curve through this point here. Let's take a look at this solution. This differential equation, 1 over x. Okay, so we have a slope field given here. Notice the negative slopes here. There's the point that we have to draw the solution curve through. Notice the vertical segments here. These are undefined slopes when x is 0, and then you have positive slopes here. So one solution curve through this could be given as that. So notice that we have to, these negative slopes tell us that our solution curve has to decrease through this point, but then we get closer and closer to these dotted lines. So you can tell this is a vertical asymptote of the slope field. And then of course it picks back up by increasing from the asymptote here. Again, remember you have to go from edge to edge. Make sure your solution curve is touching the edge. It has to touch the edge. And these arrowheads help you touch the edge of the slope field. So if you understand how to sketch solution curves through the slope field, then you can do these practice problems. So there's the first one. And the point you're going to try to draw the solution curve through is -1, 0. So you'll need to draw the slope field first, then use the slope field to sketch the solution curve through that point. Here's another one that depends on both x and y. So again, there's the point at -1, 2. So draw the slope field, then use the slope field to sketch the solution curve. That concludes this video on slope fields. If you have any questions, comments, or concerns, please feel free to email.